We're now going to look at integrals that require the use of partial fraction decomposition. So here we have the following integral, and we know that we'll need to use partial fraction decomposition because we have a fraction where we have a polynomial in our numerator and a polynomial in our denominator, and using simple u substitution won't allow us to solve this integral. So we'll have to find some new way in order to simplify this integral so that way we can integrate it. So the first step in using partial fraction decomposition is we can take this denominator term and factor it out. So we'll get x minus 3 multiplied by x plus 2. And the next step is we can use our partial fraction decomposition formulas in order to rewrite this integral. So this integral can now be rewritten using partial fractions as a over x minus 3 plus b over x plus 2. And that's because we noticed that we have the denominator in the form ax plus b. And so we can rewrite it as having a constant over ax plus b. So this is our ax plus b term. So we have one term and then the second term. So we can rewrite it as having constants a and constants b. The next step is we can go ahead and multiply this denominator through to the right-hand side. And that way it'll get rid of our fraction on the left-hand side and then simplify like terms. So we'll have 3x plus 11 is equal to a multiplied by x plus 2 plus b multiplied by x minus 3. And the next step is we want to solve for our a and b terms. And so in order to do that, we'll let x equal a value that will allow us to isolate either the a or b term. So we want to cause this term to go to 0. Either x plus 2 will go to 0 or x minus 3 will go to 0. And so we'll let the first x be equal to negative 2, and that will cause this a term to go to 0, and so we are isolating this b term and solving for b. So we'll get b is equal to negative 1, and the next x value we can pick is x is equal to 3, so this term will go to 0, and we'll be isolating the a term. And so we'll solve for a, which will be equal to 4. And now we can plug back our a and b terms into our expression and rewrite our integral. And this is easy to integrate, and we can go ahead and do that, and we'll get the following solution.